Hi guys, welcome back. So in this video we are going to talk about recyclable resources and water. And here is an outline of this video. First is recyclable, and then we are going to talk about market inefficiency of recyclable. The next topic is water. We will first introduce the water use globally, and then the allocation of water, the groundwater and the surface water, and then we will move to the inefficient allocation of water and the sources of those inefficient allocations. Finally, we will talk about water pricing and the global concerns. So first, recyclable resources. It is pretty easy to understand that there will be disposal costs. And with increasing population densities, the disposal costs also rise. And due to that, products made with virgin materials will be more expensive until people cannot afford it. And as long as quality of product is not affected, consumers will shift to materials made of recyclable products because they can control the price of that kind of product and afford the products. And some materials are easy to recycle while others are not such easy. And here are some examples of recyclable materials. Nowadays, recycling increases and recycling rates are also on the rise. So many factors can affect the process of recycling and the recycling rates, such as transportation, labor, and processing costs. Because recycling becomes more cost competitive, manufacturers rely more heavily on recycled inputs as well as product design. As shown in this graph, the municipal solid waste has increased from 5 million tons in 1960 to 48 million tons in 2010. And the recycling percent has increased from like 11% in 1960 to 35% in 2010. So we know from this graph is that the total amount of recycling is increasing and the total waste is also increasing. And the point is that we cannot dispose as much as we can. We need to recycle some of our disposal. But what is our efficient level of recycling and what is our efficient level of disposal? That would be the question we will answer in next slide. If an economic agent does not bear the full cost of disposal, then the agent will be biased toward the use of virgin materials and away from recycling. But the reality is that we do bear a certain amount of disposal and we recycle the another amount of our waste, right? So we need to find that level, find a balance between recycle and disposal. That is our second and third sentence tell us the avoided marginal cost of disposal is considered a marginal benefit from recycling, and this amount should be taken into account in recycling decision. Both marginal disposal costs and the prices of recyclable materials will affect the efficient level of recycling. And this graph explains when there is a negative externality from waste, there would be too little recycling happen. Why? So let's say the first curve at MCP, which represents the private marginal cost of consuming virgin materials and disposing them, and MCS is the social marginal cost of virgin materials, and MCS is higher than MCP because it also includes some negative externalities generated from private consuming of virgin materials, and this curve MCR represents the marginal social cost, or we can say marginal private cost of recycling, and this curve, the marginal cost of recycling, starts from the left origin, and the private marginal cost of consuming virgin materials and the social marginal cost of consuming virgin materials start from the right version. So we can say we just merge 3 lines in one graph. When we have MCP, which is the private marginal cost of consuming virgin materials, equal to MCR, marginal social cost of recycling, then we achieve the market equilibrium of recycle or market equilibrium of disposal. However, the social equilibrium is different from the market equilibrium. Why? Because there are some negative externalities from consuming virgin materials. So, if we don't take the negative externalities from consuming virgin materials into consideration, then we will recycle less than the optimal level because QP is less than QS, and QP is determined by the market equilibrium. QS is determined by social equilibrium. So the efficient level is determined by the intersection of MCS and MCR, which is the social efficient level, and the market or private efficient level is determined by the intersection of MCP and MCR, which is A, the market equilibrium. Then we are going to talk about how subsidies lead to too much consumption. And first is the definition of a subsidy. A subsidy is a payment made to producer by a government to help keep the prices of the product low enough and to encourage consumption or production. So let's see how the subsidy can encourage consumption from this graph. The original supply curve is S, and with $1 subsidy, the supply curve moves from S to S1 because it decreases the price to consumers. And from consumers' side, they have price moves from P to P1, which means the price of this product for them decreases. So the area between P to P1 is the benefit to consumer. And for producers, the quantity they can sell at the original market equilibrium is Q, and with government subsidy, the quantity they can sell becomes Q1. So that means they can increase their production or consumers' consumption of this product due to government's subsidy. And at Q1, their corresponding price is Z, because they have government subsidy, so they can keep this supply curve. And the difference between Z and P is the increase amount, or we can say the benefits from government's subsidy for producers. And one example of subsidies on raw materials is the mining law of 1872, and due to the subsidies, the raw materials are artificially treated. Consumers just consume more raw materials, and due to that, the market for recycled inputs are undermined. Then we are going to talk about public policies for recycling. Public policies include refundable deposits and taxes. First, a refundable deposit system is typically designed to be an initial charge that reflects the cost of disposal and to provide a refund that encourages recycling and help conserve the virgin materials. Deposit funds are used for beverage containers and motor oil, tires, and more, and taxing virgin materials and subsidizing recycling activities can also promote recycling. Taxing virgin materials would reduce the consumption of virgin materials. Subsidies on recycling inputs can encourage the consumption of recyclable materials. So that is all about recycling and efficiency. Then we are going to talk about water use. So humans depend not only on an intake of water to replace the continual loss of body fluids, and we also depend on food sources that themselves need water to survive, and methods of water allocation in the past and to the future by different institutions are different. Here is a graph for world water use. We use water for agriculture, manufacturing, electronic, and domestic, and the amount of water we use is increasing from 2000 to the future. So that also explains the methods of water allocation would be different for the past and for the future. And according to UN Environment Program, 90% of the world's readily available freshwater resources is groundwater, and only 2.5% of this is available on a renewable basis. So what does that mean? The rest of the groundwater is a finite depletable resource, and of the estimated total volume of water on Earth, only 2.5% is freshwater, and of this amount, less than 1% of all freshwater resources is available for human consumption and for ecosystems. So that also means the efficient water allocation is very important for us because there is less amount of water available for us to use in the future. And there are two main types of water. The first one is surface water. Surface water is a renewable resource consisting of rivers, lakes, and in many parts of the world, excess demand for water is causing greater stress for many countries in the world, and water quality is also a growing problem. So the second type of water is groundwater. Groundwater is the water found underground in the cracks and spaces in soil, sand, and rock, and it is collected in and moves slowly through geological formations of soil, sand, and rocks. And here is the surface and the groundwater use in US. As we can see, California and Texas use most of the surface and the groundwater. But water is not unlimited. It is limited. It is a finite resource. So we need to find an efficient level of water use. How to find that? First, we need to define the efficient allocation of surface water. Efficient allocation of surface water means a distribution of a renewable resource among competing users. And when deciding the efficient allocation of a renewable water, we need to think about the contemporaneous opportunity cost or the cost imposed on alternative users. And efficiency in the presence of competing users implies that the marginal net benefit should be equalized across all users. And here is a graph to show how we equalize the marginal net benefit across all users. Suppose there are two users, user A and user B, and this curve represents A's marginal net benefit curve, and this one is B's marginal net benefit curve. And this line, the combination of this solid line and this dashed line represents the aggregate marginal net benefit curve, because in this case we regard the surface water as a private good because it is both excludable and rival. So the aggregate marginal net benefit curve would be like this. So when the water supply is equal to S1, then A's marginal net benefit curve lies above B's marginal net benefit curve. So that means A would receive all of the water and B receives nothing because A is willing to pay more than B for this amount of water. And that also means as supplies diminish, the cost of doing without water is much higher for A than B. However, when water supply is equal to S0, then the intersection of the water supply and the aggregate marginal net benefit is at E. The corresponding marginal net benefits for A and B are equal to M and B0, and at that point, B would receive Q0B and A would receive Q0A. And we can also say in this case, A's marginal net benefit and B's marginal net benefit are equalized. So we call that an efficient level of allocation. And the efficient allocation for groundwater would be different because it is a depletable resource. So we need to think about the intertemporal opportunity cost, or we need to regard this problem as a dynamic problem. When withdrawals of groundwater exceed the recharges, the resource, the groundwater would be mined over time until it is depleted, or until the marginal extraction cost reaches a limited level. And in some regions, or we can say in many regions, groundwater and surface water are not physically separated. So the management of water allocation must consider the linkages of those two types of water. After talking about efficient allocation of water, then we are going to talk about the source or the sources of inefficiency, subsidy. So according to this graph, QE is the market equilibrium without subsidy, and QS is the amount of water consumed with subsidies. So when there are subsidies to irrigation, then we consume more water than the efficient level. So that is what I mean. The subsidies also cause the market inefficiency. Another source of market inefficient allocation is open access. And first, I have a question. Suppose the groundwater is abundant with many other users who have also drilled private wells. Would you expect that this type of groundwater would be allocated efficient or not? So the answer is not, because when the private well is not private and is shared by neighbors who have their own private wells, the extraction would not be efficient. Each user would assume that since other users are extracting and producing the available quantity of resource, his avoidance would be his own loss. So he would use these resources as much as he could, and there would be no resource left for the next generation, and that is not an efficient level of allocation. So many users can create this type of problems, and we call it open access problem. Pumping costs would rise too quickly because the amount of available resources is decreasing too quickly. Future users will carry the larger burden because the water available for them to use in the future is decreasing. And then we are going to talk about the third source of inefficiency, the yield-defined property rights. And first, we are going to talk about two kinds of property rights. The first one is riparian right, which allocates the right to use water to the owner of the land adjacent to the water source, and at least we think this one is very reasonable. However, when we think about the miners who first settled the West and needed water to develop their mining claims, and because the land needed was not adjacent to a water source, the miner could not use this repairing system. According to that situation, the second water right was developed, and we call that the prior appropriation doctrine, or the first in time, first in rights. So this one allows the first user had the right to transfer the water away from the stream for beneficial use. And the beneficial uses include agriculture, industry, or household use. And the first user has the right to continue using the water to the exclusion of the rights of those who come later. So according to the Carson theorem, we know that if property rights are well defined, efficiency will be achieved from the direct transferability of rights. However, the two systems we talk about just limit the transferability and result in inefficiencies. For example, the use it or lose it characteristic of prior appropriation doctrine just exacerbates the inefficiency since there is no incentive for them to conserve. And this doctrine just gives certain users the highest priority for allocation during the shortage of the water source. And this method does not take the marginal net benefit of the water use into consideration. So we say the current systems can lead to inefficiencies. And how to correct that structure? There are several methods. We can relax the use it or lose it restriction, and that would encourage conservation and allow water to move to higher value uses by allowing owner to sell conserved water. Also, we can create water markets and water banks and correct both inefficiencies and scarcity in the short term or long term. And the final topic we are going to talk about in this video is pricing, is water pricing. Water pricing is based on people's willingness to pay, and the fees are paid for service. All pricing systems and mechanisms should be geared towards conservation, protection, and efficient use of water, as well as promote equity of marginal net benefit. So it is very difficult to decide the price of water because it cannot be too high. If the price is too high, it would discourage the water use, and also it should not be too low. If the price of water is too low, there would be excess demand of water. So here are 4 different types of methods we can decide the price of water. The first one is called uniform rate structure, and the price of water under this structure is constant, would not decrease or increase due to other factors. And the second one is called a decline block rate structure, or we see the decreasing rate structure. The cost of water is decreasing when we use more unit of water. And the third one is called inverted block rate structure, or increasing rate structure. The more we use, the more we pay, and the unit of water we need to pay is increasing. The last one is called seasonal rate structure. So we pay different during different seasons, and there are 2 seasons. One is peak season, another is non-peak season, and we pay the same amount, or the price of water during the same season is constant, and the price in peak season is higher, which means it also discourages the use of water in peak season. And in non-peak season, well, the price of water is decreasing, and that means we can use more of water in the non-peak season. The uniform rate structure and the declining rate structure does not help to conserve the water because they do not give the incentive to lower consumption. The decreasing rate structure just applies to large water users like industrial users, and only the increasing rate structure and the seasonal rate structure would allow economic actors to internalize the need for more efficient use of water. One issue of increasing rate structure is that it just increases water bill quickly, and some households may not be able to afford the huge amount of water bill. So in South Africa, the right to sufficient water is written into their constitution. The increasing block rate structure they use allows the first block is free so that even poor households can afford a baseline amount of water. So this table shows the U.S. pricing for public water, and as we can see from 1982 to 2008, the increasing block rate is increasing use, and the decreasing block rate structure is decreasingly used. And what does that mean? That means the amount of water available for us to extract it is limited, and it is even decreasing, so we need to charge more for the amount of water we consumed. And here is the US pricing of water, another figure of US pricing. So the price of water is represented by the blue line, and it is much higher than other resources like electronic, like the natural gas. So that also means water is almost the most important resource of us. And let's see the pricing table for some other bigger cities over the world. So the increasing block rate again is widely used, and the second one is the flat rate. The declining block rate and the fixed fees are not used so much. So that also means water scarcity is a global issue. It is not just a regional issue or a city issue. So we need to put our effort together globally to overcome the water scarcity issue. So that is all about this video. See you next time.